Hey guys, welcome to CPM 3. This is Module 4, and we're going over 2 lessons. So we're going over lessons 2 and 3, but this is the first part. So in this lesson, we're going to learn how to solve systems of linear equations by substitution and elimination. And then in part 2, so the next video, the next lesson, we'll be applying substitution and elimination to word problems. So, your 2 definition words are what we're learning. It says 2 algebraic methods for solving systems of equations are substitution and addition. I may call addition elimination. So if I say elimination, I mean addition. Those mean the same thing. I'm used to saying elimination, and this book uses addition. So those mean the same thing. So first thing we're going to go over is substitution. And so you have your steps here. It says solve one of the equations for its variables. So what that means is, like right here, we have y equals. This is not solved for one of them because you've got x and y both on the same side. So you need to solve one equation for its variables. You're going to substitute the expression for the variable found in step 1 into the other equation, solve the equation, and then substitute the value found in step 3 into the other equation. So that sounds more confusing than it is. Basically what we are doing here, because I know that y equals 3x, in place of this y here, I'm going to replace this with that 3x. So now this top equation is going to be 5x minus, what does y equal? Y equals 3x. So we're replacing that y with that 3x. And now that equals -2. So before, I could not solve this equation because I had 2 variables and I didn't know either. Now that I have an equation with only one variable, just x, now I can solve this. So combine your like terms. 5x minus 3x is 2x. So 2x equals -2. Divide both sides by 2. And I get x is -1. Okay, we are not done yet. I have 2 answers, right? So we saw in the last video, in the last lesson, that whenever you're graphing, wherever these 2 lines intersect, okay, this ordered pair is your solution. So I need an x and I need a y. So once I get x, now plug it in. I can plug it into this top equation if I choose. But the easiest thing to do is to plug it into this equation here that's already solved for what I need. So now I'm going to take this, and I've got y equals 3x. Well, what does x equal? X is -1. And so we get y equals -3. Okay, so for your final answer, you need to write this as an ordered pair. Your ordered pair is always x comma y. So my x is -1 comma -3. This is my final answer here. Okay, turn that page. Let's do this again. This time on the next page, now I have an equation that is solved for x already. So I'm going to take that and plug it into the equation where I see this x. So now we have 2 times my x equals y plus 2. And then rewrite the rest. So plus y equals 10. So now that I have an equation of just one variable, now we can solve for that one variable. So first thing we're going to do is distribute. I get 2y. 2 times 2 is 4. Bring down your plus y equals 10. Combine your like terms. 2y and y make 3y. So 3y plus 4 equals 10. Subtract 4. We get 3y equals 6. So now y equals 2. So that's 1. I need my other ordered pair. I can plug it into this top one, but why plug it into the top one when this one here is already set for x? So now when I plug it into this second one, I've got x plus, nope, I've got y equals y plus 2. What is my y? My y is 2. So I've got 2 plus 2. So my x is 4. So now write it as an ordered pair. We've got 4, 2. It's always x, then y. Now, the first two examples have already had something solved for, right? This one has x equals. The last one had y equals. That is not always going to be the case. So this helpful hint here says, when solving a system of equation by substitution method, begin by solving the equation for one of its variables. If possible, solve for a variable that has a coefficient of 1, and it says or -1. Most of ours will just have a 1. It says this way we can avoid working with time-consuming fractions. So my concept checked here says, to avoid fractions, which equations below would you use to solve for x? So which one of these has a coefficient of 1 for x? And that would be this one right here. This one would be easy to solve for x. Well, let's just go like this. Because this x right here has a coefficient of 1. So when you look at this one here, is it going to be easier to solve for top or bottom? Which one has a coefficient of 1? Ding, ding, ding. It's this one right here. So like for example, if I was to solve this one for x, we'd have 2x plus 2y equals 13. If I'm solving for x, we're subtracting our 2y. We get 2x equals 13 minus 2y. Divide everything by 2, and I get x equals 13 over 2 minus y. Do you want to plug in 13 over 2 minus y into this top equation? This is what it means by time-consuming fractions. So you want to pick something that has a coefficient of 1. Okay, so I'm going to take this top one, and we're solving for x. So I'm just going to rewrite it real quick. Okay, so how do you get x by itself? We're just going to subtract this 2y over. And so now I have x equals. Now in the past we always wanted that coefficient first. This one it doesn't really matter, so I'm just going to keep it the way it looks. So x, 7x, nope, 7 minus 2y. Okay, you can also write that as negative 2y plus 7. It does not matter the order. So because I have solved this top one, that means I need to plug it into this bottom one. Okay, this was my first step. So here is my second step. So now that x equals 7 minus 2y, plug that in to this equation for your x, since that's what x equals. So we have 2 times 7 minus 2y. Bring the rest of it down. Plus 2y equals 13. So first, we're going to have to distribute. Bring the rest down. So now combine your like terms. -4 and 2 makes this 14 minus 2y equals 13. Subtract your 14 over. So I get -2y equals -1. Divide by -2. And we get y is 1/2, or you could even write that as a decimal 0.5. So now that I have y, let's plug it in. Now I have three things I can plug this into. I can plug it into the original top equation, into that bottom equation, or into this equation I just made. I'm going to plug it into this one here. Reason is it already has x equals, so there's nothing I have to move around. It's just plugging it in and calculator work. So we get x equals 7 minus 2 times, what's my y? My y is either 1/2 or 0.5, whichever one you want to use. So I get 7 minus 2 times 1/2 is 1. And so here x is 6. So what is my ordered pair? So it's x comma y. So we get 6 comma 1/2, or 6 comma 0.5. Okay, and you won't get many fractions like that 1/2, but that is the advantage to solving this algebraically, because that would be hard to exactly pinpoint that is exactly 1.5. If you're graphing that, how will you not know that it's, 0.3 instead of 0.5 or 0.4 instead of 0.5? And so that's the advantage of doing it this way. Okay, we've went over 3 examples. The first 2 had something already solved for. You had y equals 3x. Here you had x equals y plus 2. This bottom one we had to solve for one of the variables. In all of these so far, we've had one solution, and that one solution we have wrote as an ordered pair. But if you remember from last lesson, there are special circumstances that could happen. We could get infinitely many solutions. Okay, so we have that same line on top of that same line. And we can also get no solution. So those ones where we had parallel lines, right, that never touched, or we would have one line that the line was right there on top of each other, we can get that too with substitution. This is going to happen when both of your variables are eliminated, and we need to stress the both. Both of them have to be eliminated. Okay, when they both get eliminated, it is infinitely many solutions when your equation is true. That would be something like 7 equals 7. Scoot that over just a little bit. 7 equals 7, or maybe something like 0 equals 0. You have a true statement. It is no solution when my statement is false. So that would be something like 0 does not equal 5. Which should kind of make sense, right? If it's not a true equation, you've got no solution. If it's equal, then it's infinitely many. Okay, so example 2, solve each system of equation by substitution method. So, in this first one, I don't have anything already solved for, right, where it says y equals. So I'm going to solve this top one for y because that's the one that has the coefficient of 1. So to solve this one for y, we'd have to subtract our 4x over. These you can't combine, so we would have y equals 11 minus 4x. Okay, again, quickly what I'm doing is subtracting over that 4x. These you can't combine, so I'm just going to put them side by side. 11 minus 4x. Okay, so now that I have that solved for, we're going to plug that in to our second equation. So I've got 12x plus 3 times my y, I'm substituting that in for, so 11 minus 4x, and then that equals 33. So let's distribute first. So I'm going to get 12x plus 33. 3 times negative 4 is negative 12x equals 33. So if you kind of notice something here, when I go to combine like terms, we've got 12x minus 12x. Well, that's 0, so those cancel each other out. And so now I'm just left with 33 equals 33. Well, because this is a true statement, my answer here is infinite solutions. And so as you can see, these are a lot quicker because now that my x has been eliminated, there's nothing to substitute back in to get the next equation. We're done. Okay, so that's your example of infinite solutions. So let's do one of no solution. So here, if you notice, nothing is solved for. We don't have x equals or y equals. And I also don't have anything with a coefficient of 1. We've got a coefficient of negative 6, 5, 24, and 20. So I'm going to pick a equation where I know things are evenly divisible. So like for example, I can't divide 24 or 6 into 10, so I don't want to use that one. But I can divide a 5 or a 20 into 0. So I'm going to pick this one. Okay, and if we choose to solve this for x, we've got 5x plus 20y equals 0. I'm going to subtract my 20y over. So I've got 5x equals negative 20y. Divide by 5. And we get x equals negative 4y. Okay, and you did have to solve that one for x because if you switch it, you'll get 1/4 y. So now that we have a variable solved for, let's plug it into the other one. So I'm going to plug it into this top one. So I've got negative 6 times my x is negative 4y. Let's get this over a little bit. And then bring everything else down. So minus 24y equals negative 10. Multiply here, we get 24y minus 24y equals negative 10. Well, same thing happens here, right? 24y minus 24 cancels each other out. So now I am left with 0 on this side and a negative 10 on the other side. Does 0 equal negative 10? No. And so because this is a false statement, this one is no solution. Okay, let's try one more example of substitution. and then we are going to move on to addition or elimination. So this one here, nothing is solved for, right? We don't have y equals or x equals, but I do have a variable with a coefficient of 1, so we're going to solve this one. So we're going to get x equals -1 plus 4y. Okay, so quickly, to get x by itself, because it's a -4y, I now have to add that over. So I get x equals, I can't combine, so -1 plus 4y. You're just adding over that 4y. So now that I've solved that, we're going to plug that into the second equation. So in place of this x, we are substituting in all of that. So I've got 6 times -1 plus 4y minus 3y equals -6. Distribute. We get -6, distribute here, plus 24y minus 3y equals -6. So combine your like terms. 24 minus 3 makes that -6 plus 21y. Goal is to get y by itself, so we're going to add this over. So I get 21y equals -6 plus 6 is 0. When this happens, you guys a lot of times will tell me that this is a no solution. But did both of my variables get eliminated? No, they did not. So from here, don't stop. You can still keep going and solve for y. How do you get y by itself? Divide by 21. And so we get 0 divided by anything is 0. 0 is a number. So now take that and plug that into y to solve for x. So we get -1 plus 4 times 0. 4 times 0 is 0. And so I am left with x equals -1. So my ordered pair is always x comma y. So we get -1 comma 0. When you get a variable equals 0, don't stop there. Still continue to solve. 0 is a number, okay? And so I purposely did this one after doing these special ones because a lot of times they'll get confused for a no solution. So just kind of keep that in mind. If your variables do not get eliminated, then you have a solution. Okay, so that was 3 pages of substitution. So now let's do some elimination. For elimination, here are your steps. It says rewrite each equation in standard form of ax plus by equals c. If necessary, multiply one or both equations by a non-zero number so that the coefficients of the chosen variable of the system are opposite, so one positive, one negative. Add the equations. Find the values for one variable by solving the resulting equation. Then find the variable of the second one by substituting it in. So, I call this one elimination. Again, this book calls it addition, and I sort of like both names because what this does is you're going to eliminate one variable, but then you have to remember to add what's left. So like right here on A, if you notice, we already have opposites. You've got one positive y and one negative y. So what is 1 minus 1? That's 0, so that gets eliminated right there. So now we're going to take what's left and add what's left. So we've got x plus x to give me 2x. 7 plus 5 gives me 12. And then solve. So we get x equals 6. So then, just like before, once you figure out what one of them equals, plug it in. You can plug it into either one, top or bottom. I'm going to go to this top one here that has all positives. But we could substitute it into the bottom one as well and still get the same answer. So now that x is 6, we've got 6 plus y equals 7. Subtract your 6, and I get y equals 1. So my final answer is always x comma y, so 6 comma 1. Okay, so a little bit different steps, same result. People either kind of like one or the other. They either like substitution or elimination. And that's perfectly fine. You don't need to master both of these. You just need to be good at one of them. Okay. B, do the exact same thing. So look to see if you have opposites first. And we do. Again, we're going to eliminate my y's. -3 plus 3y is 0. So I'm eliminating my y's again. So now, add what is left. So 6x plus -x is 5x. -6 plus -4 is -10. Divide both sides by 5, and we get x to be 2. So now plug it into either. Just solve for y. Let's go with the top one again. But again, we could go with the bottom one. So I've got 6 times x. My x we found to be 2. Minus 3y equals -6. So 6 times 2 is 12. Bring down everything else. I'm going to subtract 12. So I've got -3y equals -18. Divide by -3. And we've got y to equal 6. Oh, guys, I messed up. Did you see my mistake? Oh, this is annoying. Right here, -10 divided by 5 is a -2. So I have to back up to here. So x equals -2. Can't really fit a good negative in there. Okay, -2. So we should have done 6 times -2, which is -12. So now instead of subtracting 12, now I'm adding 12. So now I'm left with -3y equals -6 plus 12 is now +6. Divide by -3, and y is -2. Sorry, that's probably confusing now. So my ordered pair is -2, 2. So if that one was confusing, come see me, or just skip it. But that was my bad. Okay. So with A and B, something already eliminated. That's not always going to be the case. So this helpful hint here tells me, make sure to multiply both sides of an equation by a chosen number when solving by the addition method. A common mistake is to multiply only the side containing the variables. Okay, so we are multiplying both sides of the equation. Okay, what I am doing here, because because nothing cancels out, I'm going to take this and see if I can multiply something by a number to get it to cancel. So for example, because this is a 1x, I can easily multiply this whole thing by 7 so that my coefficients here match and I can cancel. You also want to make sure that they are opposites, and so I'm going to multiply by a -7. Okay. So -7 times x is -7x. -7, I'm basically distributing that -7 to everything in this equation, okay? -7 times 5y is a -35y. And -7 times 49 is -343. So, after we multiply, I am now no longer looking at this original first equation. These two are now my equations, the original second one and what I just multiplied by are my 2. So now 7x minus 7x, that cancels at 0. And now I'm going to add what is left. So -4y minus 35y is a -39y. 31 plus a -343 is a -312. Now to solve for y, we're going to divide by -39. And that comes out to a nice, pretty 8. Okay, now that I have one, plug it into the other one. Now we have 3 different options. I've got this -7x equation. I've got this positive 7x equation. Or, let's see if I can do this. I don't know what I did. Oh, this is maddening. I'm trying to move that little yellow squiggly. Okay, let me try one other thing. Okay. Oops. That's my puppy. Okay, I was trying to erase that yellow. I thought if I did it in a different color, I could go back later and erase it, but of course I can't. So I can also plug it into this original equation here. That original equation was x, let's just put this back in black, was x plus 5y equals 49. Reason I'm making such a big deal about that is because I am going to plug it into that original one. I want to plug it into the equation that has the smallest numbers. So now when I plug in my y, I've got x plus 5 times y, which is 8. That equals 49. So I got x plus 40 equals 49. Subtract over your 40, and we've got x to be 9. So now what is my ordered pair? X comma y. So 9 comma 8. Now let's try one other one. And C, all I had to do was multiply one equation because I had a coefficient of 1. On this one here, I've actually got to multiply both of these. I can't just multiply one thing by something to get it to cancel out. Okay, that's what's nice about having this one just be a coefficient of 1. So on this one, I'm going to try and eliminate my x's because if you notice, those are already opposite signs. My y's are both positive, which still isn't hard to do, but because these are already negative, I'm going to cancel out my x's. And so something I can multiply a 2 and a 3 to would be a 6. So I'm going to multiply these both to be able to get to a 6. So I need to multiply 2 by 3. So distribute that 3 to everything, including that 10. So we're going to get negative 6x plus 9y equals 30. And then I'm going to multiply this bottom one by 2 because I know 3 times 2 will get me to a 6. So multiply that again to all three things. So we'll get 6x plus 8y equals 4. So now I have opposites. So I can cancel out my x's. And we will add what's left. So 9 plus 8 gives me 17y. 30 plus 4 is 34. Divide by 17. And I have y is 2. So now plug it in. I actually have 4 different options now. I've got the original 2 and then what I multiplied. Now I'm definitely not picking the ones I multiplied because those are bigger numbers. I can pick the top, but I'm going to go ahead and pick this bottom one just simply because it's got all positive numbers. So now I've got 3x plus 4 times my y is 2. And that equals 2. So I've got 3x plus 8 equals 2. We're going to subtract that 8 over. So 3x equals negative 6, divide by 3. And my x is negative 2. So now my ordered pair is x comma y. So negative 2 comma 2. And then on our last page, just like before, we have special cases. And my special cases is again when and if both variables are eliminated. We get infinitely many when my statement is true, and I get no solution when my statement is false. So on A, solve these by addition method. So I can see here that because of my negative 1, we can multiply by 5 to get to this 5. So 5 times negative x is negative 5x. 5 times 2y is a negative 10y. And 5 times negative 4 is a negative 20. So the whole goal was to cancel out my x, and that's what we have done. But if you notice, everything here is opposites, right? 10 minus 10, that cancels, so I'm left with nothing over here, which is my 0. Then on the other side, we've got 20 minus 20, which is also 0. Because this is true, this is my infinite solution. And in fact, anytime you're using addition, you'll always get 0 equals 0. On like substitution, if you notice over here, nope, not that page. Here, you got 33 equals 33. You'll get number equals a number. On addition, it's always 0 equals 0. Okay, then on this one, on B, I don't have a coefficient of 1, but I do know that I can multiply 4 by 5 to get to 20. So I'm going to multiply by 5, but remember we want opposites. So because this is positive and positive, I need one of them to be negative, so I'm going to multiply by a -5. So distribute that to everything. So -5 times 4x is -20x. -5 times -6y is a positive 30y. And -5 times 1 is -5. So my x's cancel, and that was the whole point. But I've got -30 and a positive 30, so that cancels as well. So we've got 0 equals. And then here, when I add what's left, 3 plus a -5 is a -2. Well, 0 does not equal -2. So because this statement here is false, this is your no solution. And so these false statements will always be 0 equals some number. So maybe 0 equals 8, something like that. All right, our last example. Solve the system equation by addition method. So if you notice here, if I want to eliminate my x, I can multiply 2 and 3 to get to eventually to get to a 6. So I'm going to multiply this by 3. I'm going to multiply this one by 2. Since they're already opposite, we don't need to worry about negatives. So distribute that 3 to all 3 things. So I get 6x minus 9y equals 12. Distribute this 2 to all 3 things. So -6x plus 4y equals -12. So now my x's cancel. That was the whole goal. And so let's add what's left. So -9y plus 4y gives me -5y. 12 minus 12, that cancels, so when that cancels, we're putting in a 0. This is another one where I'm telling you, don't stop. I have not had both variables eliminated, so I have a solution. So keep solving. How do you solve for y? Divide by -5, and 0 divided by anything is 0. So we get a number. 0 is a number. So then take that and solve it for the other one. So it doesn't matter what we plug this in for. I'll just go with the top one. So I've got 2x minus 3 times y. My y is 0 equals 4. 0 times anything is 0. So I've got 2x equals 4. Divide by 2. And my x is 2. So what is my answer here? 2, 0. Okay, these are very different things. This is, again, a lot of times people will stop right here and give me a no solution, and that is a solution. Okay. All right, that's all I have for this lesson. Let me know if you have any questions, and pause this video and rewind it as much as you need to.